Grade 11's lesson 2 is on exponents. So we know the number system, we know what we're working with. Now we're getting into exponents. So you need to copy either in your book on page 1. There are all of these laws of exponents that you have been taught 4 years ago in grade 8. You already know them. We're recapping and we're doing them more and more difficult. This is the way that the syllabus works. You will never get rid of it. From grade 8 you did exponents, it's always there. It just gets progressively more difficult. Okay, so in these laws that you have written down, you know from grade 8. Now listen carefully, I want you to know the little rhyme or recipe. You were taught what? Tell me the wrong thing quickly. What is this rule? If you time the add the exponents, which is in essence, I know right, but you're not saying it right. So in other words, if I have a sum like 2 to the 3 times 3 to the 2, if you time, you add the exponents. What's wrong? That's it. That's what I want you to say in your mind every time, like a grade 8 child. When you time and the bases are the same, you keep the base and then you add the exponents because it's crucial. Because the child over here that said, I know something about adding exponents, doesn't really know what's going on. The bases have to be the same. Let's talk detail. In something like 2 to the power 3, we call the whole 2 to the power 3 a power. Okay? I know we say it 2 to the power 3. We should actually say 2 to the exponent 3. It's just a talking habit that everybody's gotten into, even me, even you. But okay. In actual fact, the whole thing is the power. The 2 is called the base, and the 3 is called the exponent. Are you with me? But I'm not going to get out of that habit, so you hear me. When you time and the bases are the same, you keep the base and you add the exponent. That's exactly what it says, and you've been doing it forever. This one says if you divide and the bases are the same, you keep the base, because it's important, because sometimes you want to do something to that base as well. Even if it's 2 to the 3 and 2 to the 4. Sometimes you say, okay, well I add the exponents, I think I must time the bases. You tell yourself all the time, if the bases are the same, you keep the base and add the exponents. You will never do it wrong. That little rhyme in your head all the time. Bases are the same, keep the base, subtract the exponents. What is this law all about? What are you doing to the exponents? You are multiplying them. You're timing them. The law for this exponent is when there's a bracket in between them. In every sum, will you always be timing exponents? Only for this rule, which I'm going to talk about a little bit now again. If there is a bracket in between and it's only one power, you are going to multiply it. And can you just write mn? No, right? Because you don't have to write the multiplication sign. You can also write multiplication as a dot, or you don't have to write anything that still means you're multiplying. Are you with me? All the variations of writing, the notations of writing. So then I time the exponents. So then why am I writing this one down? So it feels like same thing. Because it doesn't matter if there's 1 or 2 or 3 bases inside here. All of them, the exponents are going to be timed with m. And what are they at the moment? 1. So it's 1 times m is m, and 1 times m is m. Exactly the same if it's division. So you're still going to time in the exponents and get to the power m and m. Same thing. So then what am I pointing out here with the last one? That does not apply if there's a plus. This rule for timing and division only applies if those bases inside were multiplied or divided. There is no exponent laws. Exponent laws for plus and minus. There's other things that you do then. No exponent laws for plus and minus. So what will I do with that then? It depends on the sum, and we'll look at one of them just now. So if there's a plus there, you cannot say it's a to the 1 times m and b to the 1 times m. It's not true. If this had, for instance, been a 2, let's take an example. If it's a plus b to the power 2, what do you do then? write it out twice. That's it. But can you see how easily your brain can get stuck on one method? And just said if there's brackets, time the exponents in. Only if it's all multiplication. So for this one, you'll have to write it out twice. And then you're going to do a what sum? A FOIL sum. Where you are going to get a square and you are going to get b square, but you're also going to get a middle term, which this child didn't do if you just multiplied it in. So you have for the middle term 1ab plus 1ab giving me? Are you with me? You've got to know that you know the rules. Okay, let's have a look at some revision from previous years. If we have to multiply, definitely, would you think exponents when you saw this sum? Because you know that math teachers are very lazy. We only know two things basically, which is simplify and solve for x. Simplify and solve for x. What would this question say? Simplify. Because there's no equations on the board, so I won't say solve for. You with me? So now I just say simplify. But it's 7,000 types of sums. So you could identify when you see the sum, I think I'm busy with exponents. So how would I do this sum? What's the first thing you see? And different ones of you would maybe see something else. What did you see? Say again. Same bases, the a's. So the bases are the same. You keep the base. But what about the 2 and 3? Let them just wait a second. What about the bases? If the bases are the same, you keep the base and you add the 2 and the 3, giving you 5. And the rest? The rest you were taught in grade 1 that 2 times 3 is 6. And in grade 8, that b to the power 0 is 1. Now if you just give me this answer, you're perfectly right. Okay, but I would like to see that that was 1. Especially if the sum becomes more difficult, because it's going to get way difficult. So a good thing to show the marker, matric end exam, I know that anything to the power of 0 is 1, except if it's 0 to the 0, are you with me? Because they didn't write that law here, we looked at it yesterday. Usually we've got 0 to the 0 is equal to undefined. Anything to the 0 is 1, except for 0 to the 0. So I think we're testing that. So let me give them something to give me a mark for. So that's equal to 1, and the answer is 6a to the power of 5. If you just write the answer, am I going to give you your full marks? Definitely. But when we get to more difficult sums, you must always ask yourself, what did Mrs. van Skalkwyk want me to write here? What is she testing? Which of the rules is she testing? Let me show her I know this, I know that. Are you with me? I'm trying to teach you what they're looking for in a matric end exam. So give them what they want. Not, but I can do anything. If the answer is right, you've got to give me the marks. You also see sometimes I don't. Because if you don't have the correct steps there, because sometimes you can do it on the calculator and you have to show the steps. So you're not going to get the full marks if you only write an answer. So in this case, yes, I can see you know that that is 1. Because where did it disappear to other than it's 1? So if you didn't write it, I would give you the marks. But I would like to ask you to show me more rather than less. Okay, let's have a look at the second example. What am I testing? What's going on here? Which law? The one with the third one, the one with the brackets. Well, actually the fourth one, but who cares? It's the one that you time in, right? Any problems that I can't time it in? If there was a plus or a minus, no problem. It's all multiplication and division. All the exponent laws only work for multiplication and division. If it's adding and subtracting, you've got to have other stuff that you can use. So then what am I going to do with this exponent? You're going to time it in. But where do I start? With the negative first. So actually this whole thing has been written out twice. So there's a negative times a negative, which will become a... Do you have to write the plus? No. Okay. Then the 3 will also have to be squared. It's actually 1 times the 2 there is going to be 3 squared. Write 3 square or write 9. I'm happy with both of them. You've got the idea. With you first write 3 square, but at the end of a sum, please don't write the answer as 3 square. The answer is 9. So you can have an extra step or less steps. Then it will be a to the 6, b to the... Ah, excellent. Remember that little ninja 1 there that you can't see. And then it will still be at the bottom, A5 and B3, which you can't leave away. And then in your last step, what are you going to do now? Which rule? Which rule? When you divide and the bases are the same, you keep the base, subtract the exponent. So the A's are going to become A to the power what? 1, because it's 6 minus 1. So that's going to be A to the power 1. Do I need to write the 1? Oh, what about the 9? It'll stay there. And I don't have to write the plus. And what about the B? It'll be B to the power? Okay, so if you want to put it at the top, it's going to be B to the negative 1. But usually we do it, the smaller one taken from the larger one. So it'll be 3 minus 2, and there will be B left at the bottom. So that'll be B. Is it wrong if you got 9A, B to the negative 1? Not really. If they didn't specify that they wanted it as positive exponents, it's not really wrong. Normally the generalization is like, will you ever give me an answer like that? I hope not. I hope you're going to tell me that that is 8. I was fearful that I was going to get 6. That is 8. Are you with me? You don't write that. You give me the answer as 8. Same thing over here. It's a generalization that you don't write B to the negative 1. We always make it positive exponents. Okay. So for the next one, same thing. Not really. A little bit of a technique that I want to show you here, because there are, in the next few days that we're going to be doing exponents, we're going to have quite a lot of things I'm going to tell you. Listen, your new middle name is alternative. Because in maths, I can guarantee you even the simplest sum. If you come to me, I can give you an alternative. It might be a page-long alternative because you really wanted an alternative, but there will be an alternative for every sum. Are you with me here? Yes. Especially with exponents, because there can be various ways of doing it. Because normally we have order of operations, right? You have to have order of operations. But in this case, there was a few things that you could do first. Couldn't I first divide the 8 and the 2 before I do the exponent? You agree with me? But I don't want to. Josh wants to time it all in first. Is he right? Okay. Another thing that I want to show you today is if the exponent is negative and you've got a fraction. Because listen now, alternative. If it's a fraction, what can I do?
You can swap it, the places.
Everything. It's like any fraction. So if it's to the power negative 3, this will now be to the power. I have to have a reason why I do things, and I don't really have a reason for what I just did. Are you with me here? But I want to show you alternatives. And maybe I'll take 2 steps longer than the guy that just timed it in or first simplified, but we're going to get to the same answer. So I want your brain to be developed and know there are alternatives for every sum, especially with exponents. Okay. Sometimes you don't have a choice. Order of operations has to be followed. But this is all multiplication and division, and all the exponent laws goes according to them. So if you wanted to do something earlier, later, it's fine. Still, I can go and simplify that first and say that 2 goes into 8 4 times. Are you with me? Didn't we some way say that we've got to have prime numbers always when we're busy with exponents? So can I write 8 as 2 to the power 3? Yes, you may. I'm not going to, but you may. So if you write it as 2 to the 3, then we can subtract exponents. We're still going to get to the answer of 4 eventually. So is it really necessary? Sometimes it really is. But ma'am, sometimes this, sometimes that. That's ma'am. You sit in a situation and you must assess, am I going to do this or am I not going to do this? Are you with me? I want your brain to develop and know there are variations. So if I did want to go do that, it would give me 4. Do you agree? Okay. And then we've got still y to the power negative 4. Because now what I can do is I could already time in that exponent. And get y to the negative 12 and get x to the power 9. But please be careful with that 4. So now that 4 is also to the power of 3. And what is 4 to the power 3? Who knows? 64. Excellent. You show me nothing, I'm happy. And can you use your calculator? How do I know you've used it or not? So there are certain numbers that I would like you to know the moment I tell you. 2 to the 3, just now I asked you, is 8. 2 to the 4 is? Okay, 27 can be written as? 3 to the 3. You know that you can do it on a calculator with fact, hey? Shift fact. But it's good that you know powers of 2 and powers of 3 for exponents because it will help you go much quicker and much easier. Are you with me? So if you know that 4 to the power of 3 is 64 immediately, you didn't show me anything. What about the other child I said that writes 2 to the 3, 2 to the 1, then 2 to the 2, then 2 to the, what would it be then? 2 to the 6. But 2 to the 6 is still 64. Right, our fourth example. Where would I start? Look carefully. I didn't miswrite, make mistakes. This is multiplication to the power of 2. There's a plus in between. There's a plus in between. Is this exponent yours?
No.
Okay, is this?
Yes.
Okay, excellent. That's what we're testing here. So help me in the first part. What do I do?
Distribute the 2.
Okay, let's do the 2. But just because you said that, I'm not going to. Because your middle name is? Alternative. We sort of get stuck in our ways. We see it, we want to do it. Are you right if you wanted to put it in there and say 3 squares 9? That'll be x to the 6. 3 squares 9 again. X to the 6 again. And when you add that, you're going to get to x to the 12. What am I going to get here?
Also x to the 2.
Any which way. Are you with me? I haven't forgotten about that. And so this will then now be
81.
81. If you want to first write 3 squared, then 3 to the 4, then 81 is alternatives. And then we've got x to the power 12. Then for this one we need to FOIL. Write it out twice. So we have FOIL. The first ones when we time them we get 3 times 3 is
9.
x to the. Careful now. What do we do with the 3's? You want to time them, we want to add them. You've got to know that you know. When I time, I keep the base and I add the exponents. You hear me speaking to myself all the time. All right. Then we've got this one. So when I time again, every single time that you're timing, you're back in grade 8. You first time the sign. A plus times a plus is a
Plus
3 times 3 is
9.
x to the 3 times x to the 3 is x to the
6.
and then we've got
Another one.
another one which gives me again
The same
plus 9 x to the 6
thing.
and then we have
Another one.
another one plus 9 x to the
6.
6 and then we can add them all together. What alternative was much better than what I just did?
FOIL.
Could have added this and
They are
Like
like terms. Really? I shouldn't have done that to myself. Am I going to get you the right answer? Yes. Absolutely. But sometimes I choose a wrong thing and make it more difficult on my life. I'll get the full marks, but it might be 3 lines longer than yours and you've saved 2 minutes. Are you with me? But we're both correct as long as the math stays correct. Are you with me, guys?
Yes, ma'am.
Lots of alternatives that we can use, and I'm going to erase it now to show you. Because now, what would this answer be?
9
They are all,
times 4.
they are all like terms. So we add
9.
the numbers in front. What are they called?
coefficient
Coefficients. 9 plus 9 plus 9 plus 9.
36.
36.
Okay, let's check it out. So if you want to, you know how I just did it. Just do that in pencil as well, just to see. Or you can leave it that way, it's fine. if I did want to then say 6x to the 3, but careful now, when I add like terms. Doesn't something have to happen to the 3 and the 3 then? You got to know that you know your laws. When you're adding like terms, you only add the coefficients and the variables stay the same. Can you hear how you can confuse yourself? Okay. So then when I add them in, so I've got to go say 6 squared gives me
36.
36 and x to the power of 6. And then? And then that's that. We like in maths, if it's easy to get work, and the answer is 5. Then we feel so lacquer. But that's the answer. You can do nothing to that because they are unlike terms. And so then that's it. This has a binomial answer. Doesn't matter what you do. Don't start going crazy and say, but maybe I should factorize. Can you factorize here? You can take out 9, I think. 9 and x to the 6. But why would you want to do that? Remember that factorizing has a purpose. In grade 10 it was because we said so. Because we had to teach you how to factorize. But now whenever you factorize, there's got to be a purpose. And the purpose is simplification. If you factorize this, you're not going to simplify. There's going to be no purpose. Alright, last one for the day. Simplify this for me, please. Typically again the math, hey, simplify. What is there to do? Did you realize that we were busy with exponents here in the sums? This one?
Change everything at the bottom to the top.
Okay, so you want to write the wrong thing for Willie, by the way. If you take it to the top, you want to write? Is that what you want to do?
Yes, and then we multiply.
Okay, and multiply what?
Multiply both terms. Right? I mean, multiply.
Like this?
Yes.
It's not right. Okay, careful. That law of bringing the bottom to the top and the top to the bottom and changing the signs also only applies for multiplication. Not if it's minuses and pluses. You cannot do that. Some people will tell me, but man, look what I do. I'm taking that one to that side. Then I'm ignoring the plus here and taking that one to that side. It's wrong. You cannot take it to the top. Are you with me? I'm making a point here. The rule about taking it to the top would be fine if this was multiplication. And then you would still say times there at the top. Okay, can I just finish? I'm going to ask you now. Okay. So that you cannot do. What you then can do is, do you have another option?
Don't you subtract the exponents?
No. It's pluses and minuses. Careful. The laws are only for pluses and are only for timing and division. It's plusing and minusing here. And even if just the top was plus or just the bottom was plus, you don't just have time and divide. You cannot do that. What you'll have to do with this plus and minus stuff, the only exponent law that you can have, and for a minute I'm just going to leave that x plus y like that, and change the bottom one into, instead of over 1 right there on its own, that one I can change into 1 over x. No problem. This one I can change into 1 over y, but I cannot take it both to the top because it's not multiplication. Okay, all of them are not going to look like this in a test, but when you see something like this, you need to hear what I'm saying. Only laws for multiplication and division. So now, what must I do? Man said it's exponents, but what if it's not? How can I solve this equation? It's got nothing to do with exponents, by the way. The only thing it's got to do with exponents is changing the negative into a positive. That's exponent laws. But the rest, how can I change this?
You make the denominators of both denominators the same.
Okay, you're on the right track. You're going to have to go with fractions over fractions. There's a law in math that says when my answer is, for instance, I'll never leave it that way, ever. Never 3 things on top of each other, or 4 things even worse. You have to change it. How would I change something like that? Let's take a better example. Say, for instance, a half over 3/5. Would you leave a sum like that? What could you do with it? You change it into? That's it. Because remember, multiplication and division are basically both multiplication. Instead of dividing, I time by the
Inverse.
okay, or the reciprocal. Are you with me? And then this gives me 5 over, much better. You never leave something like that, you leave it like this. So what's wrong with this? If you're thinking, well, I don't know what to do, I suppose that's the answer. It's not the answer, because there are 3 things on top of each other. How can I do this to this? You can't. You'll have to make this bottom one fraction. If it's 1 fraction, then you can time by the inverse of that. I just want to repeat myself, there will always be alternatives. Okay. Something that I want to teach you today is, whenever you're left with 3 things on top of each other, no go. You've got to make it better. How do I do that? He was on the right track. So you've got to make that 1 fraction by getting the denominators the same you're doing.
Multiplication.
LC. Alright, so what is the lowest common denominator of x and y? Okay, so I'm reading that top part there and saying, shush, just stand there, wait a second for your turn. The bottom, the purple bottom. I'm going to change that into LCD. Bottom was timed with y, so the top must be timed with y. So what does this become?
Y.
Are you with me, guys? It's not easy. So for this purple bottom part, I'm getting the LCD of x and y, which is xy. Time the bottom with y, time the top with y. I time the bottom with x, so I'll time the plus 1 with x. Are you with me? Following everything there? Looks like it's getting worse and worse and worse. But remember, we've got a mission. We don't want 3 things on top of each other. We want to change it into multiplication of the reciprocal. So we're going to change that top black x plus y into multiplication of xy. Y plus x. And x plus y. Okay, but do I do y goes into y, x goes into x, plus goes into plus? The essence of it is wrong if you're thinking there. It's got to be a factor, so you put it in little brackets there, and then the factors can cancel out. We didn't factorize, but put brackets around it, that's a factor. So that this answer, believe it or not, is it's much better than that. But this is a higher level sum. What did I try and teach you here? Something important in maths. Whenever, normal fractions, that's normal. But when we've got algebraic fractions, we never want to leave 3 things or 4 things on top of each other. For that, you need to make it 1 fraction at the bottom and 1 fraction at the top. Well, it's not really 1, but just put some brackets around it so that you can simplify. And whatever you do, it has to simplify. If these things didn't cancel out, that's okay. But then everything would be at the top and everything at the bottom, but there's just 1 fraction, not 3 of them on top of each other. Okay? There's the homework.